Section 1.6, page 4. So one thing we hadn't really discussed yet is we're dividing by square roots of some variable that is to a power. Keep in mind, although the answer of a square root, of an even root, is always positive, it's positive because you can think of the absolute value of the squared variable. And any variable squared will be positive, but that means we could have a positive number input, or a negative input. But in our case, are the x values less than 0 because x is tending to the number line's negative side, or are x's greater than 0 because we're headed to the right side or positive side of the number line? So we need to keep this in mind, and you'll see where this comes in. Example 6, we're asked to take the limit of a function. The first thing that catches our eye is it's to infinity. Infinity is where we want to look at the denominator. Check, I have a denominator. Find the highest variable exponent. But in this case, it's inside that radical. So I really should be dividing everything not by x squared, but the square root of x squared, which we just saw above is the absolute value. But because this question asks for positive infinity, then when we're going towards positive infinity, we can just use positive x, not negative x. But you'll get to see an opportunity for negative x next. So back to the problem, no radical, I'm using an x to divide by. When there is the radical, I'm dividing by x squared inside of a radical, which can just be written individually beneath each term as a divisor. So I need to simplify so that I just have a 3, no simplifying, simplify to just have a 4, and no canceling, no simplifying. Limit is still here because I still have x's on the right side. But my variable goes away when I plug infinity in, just like the limit goes away when I plug infinity in. Any number over infinity turns into 0. And as I simplify accordingly and take the square root of 4, I've got my answer. Example 7. Now I'm going to negative infinity, the left side of the number line. This is the exact same problem as above. I don't know if you caught that. As I find my largest variable exponent, the x to the squared, because it was the same as above, now I'm going to negative infinity. So I need to be plugging negative x in where I don't have the radical symbol. So if I have the radical symbol, it's just the square root of x squared. But if I've taken the square root, but we're going to the left side of the graph, the input would be negative x's that were squared to give me this x. So now as I go to bring this in side, I'm ready to start simplifying. Notice x divided by negative x is -1, and -1 times 3 is -3. No simplification needed here, and we're just canceling terms in the only other spot. But what ended up happening, the big change from the problem above to this one, is after I got rid of limit, because I plugged infinity in and set numbers over infinity to 0, I can still take the square root of 4 to get 2, but our 3 had been negative, so that's the big difference. Keep in mind also, I plugged negative infinity in here because we were taking the limit to negative infinity. But whether you've got a number over positive infinity or a number over negative infinity, the result is still 0 because 0 is neither positive nor negative. Last example to look at. What if you have a radical in the function but no denominator? So this is hard to read, but basically I have a radical and I probably have it added or subtracted with another non-radical term. So you can think of turning the question into a fraction by putting it over a denominator of 1. But the key here is that we need to multiply both the numerator and denominator by the conjugate of the numerator, because, well, we only have a numerator really that exists. Hopefully you remember a conjugate, that if you have a binomial times the same binomial, but the sign in between the terms of the binomials is opposite, then doing FOIL, distribution, whatever, you're going to always end up with the first term squared minus the second term squared. So what we've done is we've taken this radical, and instead of saying plus a value, it was plus negative x, but we don't write plus and negative, we just have minus x. So I'm going to take this term and write it first. I'm going to keep the x last, but I'm going to turn that minus into a plus, and whatever I write on the top, I need to write on the bottom. This is just me multiplying by a giant 1, because we can always multiply anything by 1. Squaring the x squared minus 2 just takes it out of the radical. Remember, we're going to have a minus in between terms, but squaring the x gives me x squared. This should always result in some sort of cancellation from a term or multiple terms inside of the radical. So after those two add to 0 and I just have a negative 2 on top, I now have a problem like we've been solving all along. I can come find the largest variable x and divide by that. Now in this case, I kind of make this comment about, oh, you don't have a variable on top. You could just plug infinity in. Probably not a good habit to be in. You should really focus on, we're going to divide everything by x squared. Oh yeah, but wait, it's in a radical. So if it's in a radical, if I'm going to divide by it not in a radical, I need to use x. And in this case, it's going to be the positive x because I'm headed in the positive direction of the graph. So even though I wrote I'm dividing by 1 over the square root of x squared, if you can see that well enough, it's just 1 over positive x, whereas I will keep the radical for the radical, but I'll have to go back to an individual x for the non-radical term. So I've got it kind of laid out here. This radical might be hard to see that it goes all the way down. So as I simplify anything that can be simplified, still have the limit, but I'm going to get rid of it when I plug infinity in wherever x was. Anything over infinity is 0, even if it's inside of a radical. So I've got a radical of 1 minus 0, which is really just the square root of 1. And then we had this 1 that was outside the radical, so we've got 1 plus 1 is 2. But even though I have 0 over 2,